Alright, so this is what I would consider to be some pretty gosh darn good progress. Loosely speaking, I'm visualizing this as a rack mount unit. It has a MIDI input and 16 MIDI outputs, one for each channel. And I think, just for shits and giggles and maybe aesthetics, we could fit a little LCD display, which is going to have a stream of MIDI messages being received, just for, mainly for, I don't know, debugging, verifying that you're sending the correct messages across the correct channels. Might be useful. I've done LCD display stuff, so wouldn't really be difficult to do. My first priority is to be able to read and recognize MIDI, digital MIDI data. Technically, that's nothing new. I've done MIDI interface projects before. Now, my general experience in reading MIDI data is pretty much almost entirely rooted in the Atmega 328 chips, which were, you know, got the Pro Minis, the Pro Micros, anything running in the 328 chip. And generally speaking, it mostly revolved around detecting if a note is on and a note is off, and then toggling like a MOSFET that controlled a big light. That was pretty much the extent of it. This is a little bit more involved, I would say. My general approach, or at least at the moment, is to have a single MIDI input. We have a nice little opto-coupler, opto-oscillator circuit here, which uses the 4N28 opto-oscillator. That takes the MIDI input, and I would basically just have, 16 data outputs going into 16 independent microcontrollers, all filtering out the relevant MIDI data by channel. And for the controller itself, I decided to hop on the trend of the RISC-V, the 32-bit microcontrollers. This right here is the the CH32V003 chip, and this is a nice little 8-pin package. As a matter of fact, I have another one. Whoa, let me just not grab thin air. I have another one sitting right here. We can take a look at that. Oh yes. Thank you, cheap Chinese market. So, there we go. That's the dude. Nice little package. It's very, very astonishingly cheap. Like, I think I got 500 of these for all of a grand total of what, like $7, $10? So, you know, if you aren't too uncomfortable with a really tiny package, you know, when's the package size has ever mattered, really. Yeah, you can get like a massive amount of microcontrollers for very, very little money. And I'm just starting to experiment with these ones, but it is astonishing as to how much peripheral goodies these tiny booger-sized microcontrollers actually offer. Like, I would really like for an AT-Tiny that has a serial peripheral on it. That would have been awesome. Who knows, maybe there is one, and I just haven't learned how to use the search and filtering tools properly, but usually there will be about $6, $5, $4. They definitely, nothing with serial I've ever seen would be anywhere under, you know, $3 Canadian. So that, when you get 500 of these for like under $10, yeah, it's kind of hard to argue. I mean, shit, man, for these kind of prices, I'd learn a new language. Damn. So I've gotten this little breakout board, soldered in the surface mount component. Really doesn't take much. Doesn't even need an external oscillator. Just runs on a nice little internal clock. I got a little test LED connected, and it just uses power, ground, and a single wire interface to do in-circuit debugging and programming. Haven't figured out how to do serial printing. I think that is going to be extremely handy, but for the time being, to be honest, this works. I'm using a cheap MIDI USB interface. And believe me, I'm using the term interface very, very generously here. It's sufficient enough to do this test. It has a MIDI output, MIDI input, and that's really all that I need to verify that this thing works. I got a copy of Reaper installed on the same computer. I've got a routing tab sending data over to this generic purpose MIDI out USB device. And when I open up the piano roll, the editor, and click these keys, you can see that the LED is detecting MIDI data. Now, of course, the entire purpose of this whole exercise is to have 16 of these little microcontrollers, each listening to a particular port. So it's important to be able to have this microcontroller tell apart the multiple different ports. And in fact, if I were to go to the routing page and I would select channel, let's say channel 2 to be the output channel, close this, start clicking keys. There is no blinking. There's MIDI coming out, which, by the way, good job on labeling them correctly. Very, very nice. It's fine. It's like a $3 MIDI interface. I'm not gonna bother. But if I were to then hop back into the route, set it to channel 1. There you go. We are capable of discerning between multiple channels. So that's I'd say a pretty good step. The general idea is to make use of these 4-pin switches, which are using binary. You can actually key in any number of the 16 channels. I figured with the serial data input and output, as well as the LED, I should still have at least 4 pins available to me. So I would use those 4 pins to read the states of these switches, and the switches themselves will dictate what channel the microcontroller is going to be reading the MIDI data off of. I wasn't sure if this would be an elegant enough solution for a piece of music gear, but lo and behold, if we take a look at the back of the Neutron, oh, look at that. Thank you, Pixel 6 professional camera, for the stellar quality. I'm sure you'll make out the little pin switch at the back. So if it's good enough for Behringer, it's good enough for me. Oh god, the murder lighting. There is something that I can learn from Behringer developers, and it's the fact that they had posted at some point on their Facebook group where everybody who uses Behringer hardware is following. They posted about their design process and the fact that they like to design their circuits and their hardware in modules, allowing them to reuse modules across different pieces of hardware or different releases of hardware. So if I were to learn from professionals, I would say, instead of, say, making one ginormous PCB that has all 16 channels directly on them, just make small little segments, and then if something goes wrong with one of them, you can replace it quite easily. Hell, in this world of disposable, planned obsolescence electronics, maybe having a modular approach or modular design would be a selling point. Maybe. In any case, that's the general approach that I think I'm going to take. Little switches, design one circuit to read the state of the switches. The switches will determine which channel, MIDI channel, the controller will be reading from, and then just replicate the same circuit 16 times, and that's it. We got our MIDI breakout unit. Regardless of the approach, I honestly think this is pretty impressive for a controller that I have literally zero experience in. This is super cool.